Hello, good morning. Another topic we left for your own study was local linear approximation. Local linear approximation or local linearity, you can see in the heading. This is something, if you have a function f of xy, you want to approximate this function using a linear, if this function f of xy and a point is also given. A function is given, also a point x0, y0 is given. Then you can find another function called L of xy, which is a linear function. There is no terms of x square or y square, x cube, y cube, or sin x, cos x. Only linear terms, only power 1 x and power 1 y will be present. So it's a linear polynomial of two variables. You want to find such a function. What's the relation between these two functions? This L of xy will be approximately equal to f of xy for points near x0, y0. That's why it is called a local linear approximation. So you want to find another linear function. Both these functions have approximately same value near to this point. Okay, so such a function is called a local linear approximation of f of xy. So how to find this one? There is a formula for that. L of xy is equal to f of x0, y0 plus fx, partial derivative with respect to x, at x0, y0 into x minus x0 plus fy at x0, y0 into y minus y0. This will be a linear function which is called a local linear approximation of f at x0, y0. Okay, so you can find local linear approximation of function. There is a problem here. Let L of xy denote the local linear approximation of this function, root of x square plus y square at 3, 4. You want to find that one. We want to find that L of xy and compare the error in approximating f of 3.04 comma 3.98 by L of 3.04 comma 3.98 with the distance between the points. So there will be an actual value of f of 3.04 comma 3.98 and the approximate value is there. L of 3.04 comma 3.98 will be the approximate value. So when you find actual value and approximated value, modulus of their difference will give an error. Okay, and you want to compare the error with the distance between these points as we done in the previous problem. Okay, so first we'll find L of xy. For that, partial derivatives are found out, and partial derivatives at the point 3, 4 are found out. One is 3 by 5 and another one is 4 upon 5. Then using the formula, local linear approximation of f of xy at 3, 4 will be 5 plus 3 by 5 into x minus 3 plus 4 by 5 into y minus 4. Okay, this will be the local linear approximation. Then using this local linear approximation function, we are trying to approximate this function. This f of 3.04 comma 3.98 will be approximately equal to this one, which is equal to 5 plus 3 upon 5 into 3.04 minus 3, that means 0.04. Finally you will get 5.08. Now actual value, you can substitute x equal to 3.04 and y equal to 3.98 on the function itself. Okay, on this function itself. Okay, then you will get actual value of f at that point. It is 5.00819. So the error is 0.00019. Now compare this error with the distance. You can find distance is much greater than this one. So always the error obtained while approximating using local linear approximation will be less than this distance. You can compare that error with that distance. That's the kind of problem. Now in the case of 3 variable function, that is if the function is f of xyz, corresponding local linear approximation L of xyz will be having this formula. Okay, you can see it's just a generalization of previous one. Then you can do problems using this one. There are several problems given in the exercise. Here a function f is given along with local linear approximation L of at point P. Then use the information given to determine point P. Yeah, this is a question which is not to find local linear approximation. Here function and its local linear approximation is given, but at point P, the point P should be some x0 y0 which is not given. You want to find that. So that's a another type of question. You can try that. Direct questions also will be there. You can see here. Okay, 33 onwards. Find the local linear approximation L to the specified function at the designed points, designated point P. Then another part, compare the error in approximating f by L at a specified point Q with the distance between P and Q. So the same question as we seen in the example. You want to find local linear approximation, also find the error, then compare the error with the distance. There are several questions here. Try these questions and try to explore all other exercise questions as well. Okay, you can ask your doubts. So these are the two topics we left out. You can read yourself. You can make an idea of this. This will be also asked for your examination. This is also an important topic, so should not be skipped. These are the two topics. Okay, thank you.